Okay, moving on with derivatives, we're going to look at the product rule and the quotient rule today, and we'll come back and we'll do some, the next day we'll do some derivatives of trig functions, and then we'll just keep diving farther into derivatives and different kind of rules to take derivatives. For the first one we have is a product rule. What the product rule says is, so if we have two functions times each other or multiplied by each other, like a 2x times cosine of x, we do what's called a product rule. And the product rule says we're going to leave the first function and take the derivative of the second function and multiply them together. And then we're going to add by leaving the second function and taking the derivative of the first function. And we'll see how, I'll show you how that works here in this example up here. We have three examples here. So it looks like I have two functions multiplied by each other, right? What I could do is I could FOIL all of that out and then just take the derivative. If you want to do that, you could certainly do that. Or you can use the product rule, which says we're going to leave the first function. So here would be my f of x, and here would be my g of x. All right, so I'm going to leave the first function. I'm going to have 3x minus 2x squared. And what the product rule says, we're going to take the derivative of the second function. Well, the derivative of 5 plus 4x is just 4. And then we're going to add, we're going to leave the second function, so g of x, we're going to leave that, 5 plus 4x. And we're going to take the derivative of the first function, which the derivative of 3x minus 2x squared. Remember, we drop the power and subtract 1, so that's going to be 3 minus, drop the power and subtract 1, 4x. All right, for time purposes, I'm not going to simplify that for you, but all you would do is you'd multiply through then and combine like terms and you have the derivative. All right, we're all in calculus, so I think we can do that. And the next one I have is x times sine of x. Again, we have to use a product rule. We're multiplying two functions. So I'm going to leave the first one to x times the derivative of sine x. Well, derivative of sine is cosine, so cosine of x. Plus, now I'm going to take the derivative of x and multiply it by sine of x. So the derivative of x is just 1 times sine of x. All right. Again, if we'd have any common terms, we'd simplify. In this case, we don't. Moving on to number 3 here. Number 3, if you notice, looks like we'll have to do the product rule here. And I'll show you why we didn't take the product rule in the previous chapter of that function right there. Okay. So let's have to take the product rule of that first part, 2x cosine x. The product rule says I'm going to leave the first one, so 2x, take the derivative of the second one. So the derivative of cosine is negative sine of x. And then the product rule says then I'm going to take the derivative of the first one, f of x, the derivative of this guy, 2x, which is 2, and leave the second one, cosine of x. And then I'll show you right here by doing the product rule why we didn't do the product rule in the previous chapter right here. All right, so if we do the product rule, it says leave the first, so 2 times then the derivative of the sine of x, which would be cosine of x, right? And the product rule says plus then the derivative of the first function, which is just 2. Well, that's 0. And then we leave sine of x. Well, 0 times anything is 0, so that ends up canceling out. That's why we didn't have to do the product rule in the previous chapter. But anyway, again, to clean this up a little bit for you, we'd have negative 2x sine of x plus 2 cosine x minus 2 cosine x. Just so happens that our cosine x's cancel out, right? Okay. So I did simplify a little bit for you there in that one. But there's the product rule. You leave the first one, take the derivative of the second one. Then you add it to leaving the second one and take the derivative of the first one. Moving on to the quotient rule. So here we'll have a function all over another function. The quotient rule says that we take what's on the bottom and we bring it up and we multiply it by the derivative of the top. Then we subtract the top minus the derivative of the bottom all over the bottom squared. Okay. So I'll show you that. We'll do that right now. So what this up here says, look, my bottom is my g of x, and my top is my f of x. All right, so what that formula up there says, we're going to take the derivative, or we're going to leave the bottom, so we bring the bottom up, so it's going to be x squared plus 1 times the derivative of the top, which is the derivative of 5x minus 2 is 5, and then the derivative of a constant 2 is just 0, right? All right, then we're going to subtract. We're going to leave the top, so 5x minus 2, and take the derivative of the bottom. The derivative of x squared plus 1 is just 2x. All right, and then lastly, the formula just says square the bottom. So it's just going to be x squared plus 1 squared. And again, all you do on the top is multiply everything out, combine like terms. I'm not going to do that. We're all in calculus, we can handle that. But that's how we set up the quotient rule, and you guys can simplify that. All right. So again, we're going to find y prime. We're going to use a quotient rule here again. We wouldn't have to use a quotient rule if you think about it. All right, we could really just say, well, this is x squared over 6 plus 3x over 6. That's how I would probably do it. But we could use a quotient rule as well. We could use a quotient rule. It says we bring up the bottom 6 and we multiply by the derivative of the top. So we'd multiply by 2x plus 3. And then we subtract the top, x squared plus 3x, whoops, and we'd multiply that by the derivative of the bottom, which, well, the derivative of 6 is just 0. And that's all over the bottom squared. So it looks like I'd have 12x plus 18 all over 36. Let's check that out, see if we get the same thing. If I have 1/6 x squared plus 3/6 x, well, I get the same thing. Well, if I bring up, so I'll have 2/6 x plus 3/6. Well, okay, so that's 1/3 x plus 1/2. Is that the same as what I should have gotten up here? Well, it looks like 12x over, so 12x over 36 plus 18 over 36. That is, in fact, 1/3. And that is, in fact, 1/2. So we get the same thing. Just tells us the product rule works. All right. And the last example here, we could use the product rule and the quotient rule. If we wanted to, I would probably distribute. But if, to say this was an x, we distribute again. But we could use the product rule and then the quotient rule. So we do use the product rule when we take the derivative of the top. Let's do that real quick. All right, so the quotient rule says we bring up the bottom, so 7x, we take it times the derivative of the top. Well, the derivative of the top, we'll say we're doing the product rule. The product rule says, all right, we're going to leave the first one, so -3, and take it times the derivative of the second one. So it will be 3 minus 4x. All right, and then the product rule says then we are going to leave the second one and take it times the derivative of the first one. Well, the derivative of -3 is 0. And, sorry, I put a bracket in there. I didn't want a bracket in there. Okay, the derivative of the first one is 0 times, we're going to leave the second one, 3x minus 2x squared. So, but anything times 0 is going to be 0. Imagine if that was another function like -3x. We could have done the product rule and the quotient rule. Sorry, I didn't leave myself much room, but the quotient rule says that then we need to take the derivative of the bottom, so minus 7 times -3 times and 3x minus 2x squared. That got a little jumbled in there. All over 7x squared. All right. That got pretty jumbled in there. Looks like I have, let's see, 7x times a -9 plus 12x for that top, and then it'd be minus 7 times -3x minus 2x squared all over. Then when I square the bottom, it would be 49x squared. And again, I'll leave you guys to go ahead and simplify, combine like terms, and simplify as far as possible. So hopefully the quotient and the product rule makes sense, and we'll see you later.